Hello everyone, this is Ahmad for Eduonix and this is Beginning DevOps. I'd like to welcome you to the first section of this course. And in this first section, we are going to discuss why you need to watch it anyway. Because this part of the class is the only theoretical one. We are not going to run any programs here. We're not going to run any code. We are not going to write anything or configure anything. This is just a pure theoretical section. And I do not encourage you to skip this section. The nature of this class, as you probably know by now, is modular, so you can watch whatever section you feel that you need to watch, because this is a project-based class. This means that at the end of this class, we are going to build a project that utilizes DevOps. So we are going to cover several sections, each describing a tool that we are going to use inside the project. So you can skip whatever tools you feel that you are confident using and watch the sections that describe the tools that you need to know more about. However, this section, I encourage each and everybody of you to watch it, even if you know about DevOps, even if you just want to see the project at the end. I encourage you to watch this section. Why? Because you must have a firm understanding of DevOps as a set of tools, a culture, and a number of practices. DevOps is used by companies and organizations to boost their productivity and evolve rapidly. Adopting DevOps will enable you to deliver specific types of products and services at a much higher speed than when using the conventional software development path, and that is the topic of this section. So in order to understand the concepts of DevOps and why it was introduced in the first place, let's see the traditional way of software development. In traditional software development, we have two teams. The development team, those who are responsible for coding and testing the application. Once the code is verified, it can be moved to the operations team for further actions to be performed. The operations team provision the necessary infrastructure to release the application, deploy, and perform several maintenance tasks like monitoring. Even the development team may be segmented into further smaller teams like network, database, security, and so on. So what's wrong with this approach? The not so good thing about this approach is that there is a wall between both teams. Each one of those teams work in isolation. The wall in between both teams makes them work in isolation. If a problem happens while the application is deployed, or if a bug is spotted, the development team will not be aware of this until it is too late. In the real world, this model can be further expanded to include quality assurance team. Because they are working in isolation, there is another wall between the operations and quality assurance. Every team is working in isolation. Every team is working in a closed room or in a closed office, or they may be working in a separate office physically, maybe in another totally different place. So because they are working in isolation, the QA team, for example, may act as if their main target is to find more and more bugs to add to the development team. A very common scenario happens when bugs are spotted. So when a bug is spotted, the quality assurance may say, we spotted XYZ bug in the software. The development team simply replies that the code is running fine on their environment and that the problem is in the environment used by the QA team or the quality assurance team. And of course, the operations team here replies that both environments have been set up exactly the same way for both the developers and the QA teams, and that the problem might be in the code. This finger pointing and this continuous defense continues all the way down till the application is finally released. But in the DevOps way, both teams are working together in collaboration. Some of the tasks that were only performed by the operations team are now done also by the development team. So, what are the benefits of DevOps? What are the benefits of adopting such a paradigm? That will be the starting topic of next lecture, so see you next. Hello everyone, this is Ahmad again for Eduonix and this is Beginning DevOps. In the previous lecture, we have seen how the traditional way of developing software has been going, where teams are working in isolated environments. They are working away from each other. They don't have enough collaboration or enough exchange of information and exchange of work, so that if there are problems, they are spotted early enough. And we have said that DevOps basically means that all the teams are working together in a more collaborative environment. They are working through all the tasks at the same time. All the teams are in full cooperation. So what are the benefits of this model? What is the benefits of adopting a DevOps culture? It basically means that there will be a major decrease in the time spent in software building and deployment, application maintenance and bug fixing, releasing new features and versions of the application, and of course this means higher product quality, faster productivity rate, increased customer satisfaction, and of course this leads to more revenues and thus more profits. So let's have a slight historical view of, or it's not a historical actually, it is just an overview of the non-DevOps way of doing stuff or of coding applications. It's important for you to know what brought the concept of DevOps, why DevOps has emerged in the first place. The emergence of DevOps is often attributed to the rise of agile development as a modern way of software production. However, you might not have an idea actually about agile web development. To understand agile development, let's examine the traditional way that was used to develop applications. It was called the waterfall model. In the waterfall model, the following phases are followed in their order. Requirements, where all the information is gathered. Why the application will be built, which problems it will be designed to solve, what are the features that it will include are among the questions that get asked in this phase. Documentation and planning is also done at this stage. The second stage is design, where the results of the requirements phase are used to plan the application design. Notice how the phases of development are cascading under each other. They are built upon each other. When a stage is completed, the next stage starts. So we said that design takes the results of requirements phase and use it to plan the application, which includes assessing the hardware and software requirements for developing it. Then comes the implementation phase. In the implementation phase, the actual coding starts. So developers start getting their laptops and start coding the application. And this implementation phase will not start unless the design and the requirements phases are over, because based on the results of the two previous stages, the application is broken down into smaller parts that are coded and tested separately, which is referred to sometimes as unit testing. After the application is complete, coding-wise, we have the verification phase, and this phase is also known as the integration phase. This is where the separate units developed in the previous phase, in the implementation phase, are integrated to form the main application. Further tests are done after the integration, which are called integration testing, where any failures are spotted and dealt with. And then comes the maintenance or the deployment and maintenance phase, where the application is deployed for the customer to use. After deployment, of course, issues arise that need to be fixed. Moreover, by the time the application is deployed, the need may arise for new features and enhancements. Those must pass the whole cycle again, so any enhancements or any new features that need to be added to the application need to run all the way back from the requirements phase to the design, to the implementation, to the verification, and finally the maintenance. So what are the drawbacks of this model? What are the drawbacks of the waterfall model? First, no working copy of the software is available until very late in the process. So only in the verification phase will I have a partially available software. I don't have a full working copy of the software except in the maintenance phase, at the very last phase of the developer lifecycle. And once a phase is completed, there is no turning back. You cannot just return back to a previous phase to make any changes. Once the requirements phase is complete, once the documentation has been formulated, once planning is done, you cannot just return from the design back to requirements to add a new requirement, even if this requirement is necessary at the moment. It's very difficult to return back to the requirements phase from the design phase to add a new feature. It is also very difficult to go back from the implementation phase to the design or the requirements phase. Once you start coding, you cannot just go back. And of course, this has some drastic consequences. For example, bugs are spotted late. As you can see here, they are spotted late in the software lifecycle, in the verification or the maintenance phase, where I do have a working copy or a semi-working copy of the application. And of course, it takes months to finish this process. Sometimes you may be asking me, for example, we could just complete the whole phase, and then when any requirement is necessary to add, or any change or any feature needs to be added, we can just go back to the requirements phase and go ahead and make another life cycle. Well, that's not possible, because each phase may take months to finish. The whole project may take about 2 years to complete. So imagine you have a project where you want to add new features and you'll have to wait for 2 years till the application is finished before you can add new features. Of course, that is a major drawback. So of course that leads to failure to adopt changes as they arise. Although they may be necessary, although they may be required, you cannot adopt new changes in the life cycle of the project. So this was the waterfall model, and those are the drawbacks of the waterfall model. Let's have a look now at the Agile methodology and how it addressed the drawbacks of the waterfall model. That will be the starting topic of next lecture, so see you next. Hello everyone, welcome back. This is Ahmed again for Eduonix, and this is beginning DevOps section 1. In the previous lecture, we have seen the waterfall method of software development and its drawbacks, and how it takes a very long time for an application to be developed, and how it is very difficult for new changes to be adopted while the application is being developed or while the application is in its life cycle. Let's have a look at the Agile methodology and how it addresses those drawbacks. In the Agile model, software development is divided into multiple iterations. Each iteration has the following phases. Planning, and planning is not as deep and detailed as in the waterfall model. It takes a considerably less time to plan for the project, and you are gonna only plan for what's needed in the current iteration. More about that later. The second phase is called analysis, and it is also limited to the current iteration requirements. The subsequent phase is called designing, and this is where developers start designing and coding the application. This is where the actual coding happens. The result is not a full application, it is rather a working version that is missing a lot of features, because to design a fully working application is going to take several iterations. Each iteration will have very less time than the waterfall model. It may take a day or two or a week, but a maximum of 2 weeks for a single iteration to complete. Then we have the building phase, where compiling the application and any unit testing takes place. Finally, we have the testing phase, where unit quality assurance and integration testing takes place. Then we go back to the planning phase, and so on and so forth. So what are the merits of this methodology? What are the advantages or the pros of this methodology? The iteration, as we have just mentioned, will take only a few days, no more than 2 weeks to complete. And the customer is engaged through the process. In each and every stage of the process, the customer is engaged, and he or she reviews the current status of the project and also handed a working version of the application. Of course, it is not a final version. Of course, it is missing a lot of the features that will be added later, but it is working. Of course, changes are naturally adopted, as they only require being added to the next iteration. You can adopt changes easily through any stage of the project. All what we have to do is just put them in the next iteration. So the best example to explain Agile methodology is to assume that we are using it to build a car. If we are building a car using the Agile methodology, the first iteration will go as follows. Maybe build a skateboard and show it to the customer. A skateboard contains nearly nothing of the features that are found in cars. However, it will provide some blueprint for the customer to know how the product is going to work. The second iteration may bring a scooter. Again, nothing even near to a car, but it's better than a skateboard. Notice how the customer is involved in all these iterations. The product is reviewed, and comments or requests are handled in subsequent iterations. So if the customer has any comments or any features that need to be added, they will just be added to the next iteration. So let's have a look at the third iteration. We may be having a bicycle. The rider can now have a seat. It's faster than both the skateboard and the scooter. It has better steering capabilities, but still we do not have what the car does. But still it does not do what the car does. The fourth round may be a little bit closer to a car. We may build a motorbike. Of course, an engine now has been added to the product, which makes it a lot faster and closer to the intended product. And finally, in the fifth iteration, we have a fully working car. As you can see, there can be subsequent iterations after that to make even further enhancements to the car according to the customer and the market needs. So where is DevOps in that? Or how does DevOps make the Agile methodology possible, or how does it facilitate the overall process? This is going to be the starting topic of next lecture, so see you next. Alright, hello everyone, welcome back. This is Ahmad for Eduonix and this is Beginning DevOps. So in the last lecture we have stopped at defining what an Agile methodology is and the difference between the Agile methodology and the waterfall methodology in software development. And now we need to know, where does DevOps fit in? DevOps helps organizations achieve the benefits of Agile development methodologies by shifting the workflow paradigm towards faster development phases. The following are the main phases of a project developed with DevOps principles in mind. As mentioned before, in the waterfall model, you cannot return back to a stage once it is finished. This means that you will not test or integrate the written code until maybe several months have passed. Problems and bugs may and will arise into integration. Because so many changes were made without testing, fixing failures that occurred during the integration phase will take a long time. However, with continuous integration, code is integrated to the body of the application as soon as it is saved. So the first stage here, or the first principle of DevOps when working with Agile methodology, is continuous integration. The second principle, or the second most important principle, is called continuous delivery, and it builds upon continuous integration. It includes running further automated tests before merging code in the integration branch with the main branch. This makes code almost always ready for being or getting deployed. Then finally we have continuous deployment, and continuous deployment is the most advanced one, as code is actually deployed to production environment in a fully automated manner. Needless to say that only code that is fully tested in all stages and is entirely eligible to be deployed to production machines pass this phase. So how can we do it, or how DevOps does it? The strongest aspect of DevOps is the adoption of automation whenever possible. Everything in DevOps has to be done in an automated way. The least human intervention should be made. That is because, as we have said before, several teams are going to work together. Those teams are coming from different domains. Operations are going to write code that builds infrastructure. Developers are going to also write code that will work with this infrastructure some way or another. So there has to be an automation that will require the least effort from the human to get the things done. This will not only increase speed, but will also decrease the error margin. And of course, in order to automate a task, you need a tool. DevOps tasks include planning, coding, building, testing, releasing, deploying, operating, and monitoring. All those are activities done inside a DevOps culture or in a DevOps environment. DevOps tools form an ecosystem where the output of each tool becomes the input of the next one, as we're going to see later in this class. And with the advent of virtualization and, of course, following it the rise of cloud computing, this helped ease the process even more. Whole sets of tools or even a complete infrastructure can be built on the cloud using providers like Amazon AWS or Amazon Web Services, Google Cloud, among others. Virtualization, which is the most important thing that led to that whole world of cloud computing and DevOps, virtualization actually refers to abstracting the hardware resources on the machine so that a single server can run several machines at the same time. This yields massive decrease in the total cost of running a similar infrastructure using traditional physical hardware. So what are the tools that are going to be used by DevOps, or in other words, what are the tools that we are going to study in this class to demonstrate a DevOps example for you? For virtualization, we have VirtualBox, VMware, and Vagrant. And Vagrant actually builds upon VirtualBox or VMware. It is not a virtualization platform in itself, however, it is a tool that greatly eases the way of virtualizing machines. As we're going to see, it will help you write your infrastructure entirely as a code file. We also have containerization, and for containerization, we have Docker. And containerization is another form of virtualization, but a different one. It utilizes Linux containers to use the least possible amount of resources for running some software or some application. And of course, the most prominent example of this is Docker. We have Ansible, and Ansible is just one type of configuration management software. We also have Chef, Puppet, Salt, and other very well-known configuration management tools, but for this class we are going to use Ansible. For continuous integration, continuous delivery, and continuous deployment, we have Jenkins, which is a very powerful web-based CI tool. The remaining part of this class will be dedicated to briefly introducing each of those tools At the end, we're going to build a web application that adopts the DevOps culture explained earlier. The project will use the above tools to demonstrate a real-world working example. And that was all for this section. I guess by now you will have some firm understanding of the DevOps as a culture, as a principle, as a set of tools, and as a way of developing software. In the coming lecture, we are going to start with our first tool in this class, which is Vagrant. We're going to know all about it, how to install it, and how to use it to build awesome infrastructures using virtualization software. So until next section, goodbye.